Today, we're going to talk about inscribed angles. So first, what is an inscribed angle? Up until now, you've had what we called central angles. Central angles were angles that were formed from the center of my circle, hence the term central angle. So now we're going to say, hey, we're still going to have an angle inside of our circle because it's still inside, and we're going to push it back and hit the outside of the circle now. So an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So here I have my angle and all three vertices are on the sides of my circle. That's an inscribed angle. And of course, it'll have some new theorems that go with that. The second bit of vocabulary for today is called an intercepted arc. The intercepted arc is the arc that contains the interior of the inscribed angle and its endpoints on the angle. So what that means is that it's the arc here that is created by my inscribed angle. Because remember, the arc is on the outside, the angle is on the inside. So now let's talk about four properties that are the result, or four theorems that are the result of these inscribed angles. The first one says the inscribed angle theorem. The inscribed angle theorem says that this angle that's now created, called my inscribed angle, the measure of it is 1/2 the measure of its intercepted arc. So that means I have my arc out here, that this angle inside coming in, because that's the angle created, is 1/2 of that arc, AB. So if my angle or my arc here is 100 degrees, then my angle created is half of it, or my angle ADB is only going to be 50. Which then when we take it the other way, if the angles on the inside was 50, then the arc is double. Because it doubles going out, it halves coming in. Let me just show you what I'm talking about. So if I have this circle here, if my arc, as we just said, was 100 degrees, then the angle going in is 50 degrees. But if I gave you my angle being 50 degrees, then the arc measure is 100 degrees. Sorry, the arc is 100 degrees. The measure of the arc. It's half going in and it doubles going out. With that, we're just going to add on to it a little bit and say, all right, now, if we have two inscribed angles of the circle, they intercept the same arc, or a congruent arc, then the angles are congruent. Well, that makes sense. If this right here is my arc, and this is the angle, then, of course, angle C is 1/2 of arc AB. But if this is still my arc, and this is my angle, it's got to be the same measure because they're opening to the same place. The rules don't change just because it's a different arc opening up to a different place. So it doesn't change that, okay? So the two angles here, angle D and angle C, are congruent. So ADB is congruent to angle ACB. Okay, Theorem 10.8. Theorem 10.8 says, an inscribed angle of a triangle intercepts a diameter or a semicircle if and only if the angle is a right angle. Well, let's think about this for a second. If we know that it's a diameter, then going back a section or two, we know that the degrees for a semicircle, because the diameter makes a semicircle, is 180 degrees. So it makes sense that if this angle is formed off of this arc here, then it has to be half of it going in and it has to be 90. So it has to make a right triangle. So if the measure of angle ABC is 90 degrees, if and only if AC is the diameter, which makes sense. When you talk about the math revolved around it, it has to work. And our last theorem, and then some practice, talks about a quadrilateral being trapped inside the circle. So a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. That is different from when I have a plain old parallelogram or rhombus or square or rectangle. This is different. It says that now, if this quadrilateral is trapped inside here, then the opposite angles have to be supplementary, which if you think about how the math works, it has to work. Remember, supplementary means they equal 180 degrees. If we are looking at this arc here, and then we're looking at this arc here, going in, they're always half of the measure. So then therefore, if they're always half of the measure, then the two of them together would be half of what the whole circle measure is, which then would give us half of 360, which is 180. So it makes sense when you think about them, which is what I like about circles. They make sense when you think about them. So angle D and angle F together are supplementary. Angle E and angle G are supplementary. All right, let's practice. All right, so it says find the indicated measure in angle P. So first, it says the measure of angle S right here. All right, we know that angle S comes from our intercepted arc, like this. So therefore, it's half of my 60, so it is 30 degrees. That's our theorem. On the other side, I can give you the number, but it's on the other side of my paper. I don't have it in front of me, but sorry about that. I can look it up really quick. Sorry. 10.4, sorry. That would be that theorem 10.6. Theorem 10.6 says that angle S is 1/2 of the arc. So my arc is 60 degrees. So 1/2 of 60 equals the measure of angle S. So 30 degrees equals the measure of angle S. All right, so now we want to find RQ. That should be an arc. Doesn't always come out pretty when you're doing the graphics. All right, so the measure of arc RQ. So we're talking about this distance over here. I'm just going to highlight it so I know where I'm looking. So, that doesn't go up to anybody. So how am I going to find his distance? Well, what do I know? I know that here, oops, where's my orange pen? Sorry, I like to keep my things the same color. I know that here, if he's 37 degrees coming out, then QS right here doubles. So he's 74 degrees. So with that, secondly, I know that this whole distance here is half of the circle, so it's 180. So to find RQ, it's just 180 minus the 74, so it leaves us with 106 degrees. So the measure of arc RQ is 106 degrees. Okay, I want to find the measure of arc HJ and the measure of angle HGJ. So first, the measure of arc HJ. So here, I'm looking for this right here. I always like to mark what I'm looking for. So the measure of my arc, if he's 39, he doubles coming out. It's still that theorem 10.6. He doubles coming out. So 39 times 2, he doubles going out, is 78 degrees. So the measure of arc HJ is 78 degrees. So now it says, hey, what do I want to know about this angle? This angle right here, HGJ. So HGJ, this angle over here, well, he opens to the same arc. So therefore, he has the same measure. So theorem 10.7 says that if they open to the same arc, they have the same measure. So then he would also be 39 degrees. Same arc, same measure. Okay, looking at number 3. Name 2 pairs of congruent angles in the figure. All right, so we're looking at 2 pairs of congruent angles in the figure. That's that. Again, we're looking at that theorem 10.7. All right, so 2 congruent angles. If they both open up to here, that angle here would be congruent to this angle here. Remember, if they open to the same arc, they have the same measure. So, angle SPR is congruent to angle SQR. By the same token, it says 2 pairs of congruent angles opening the other direction. So now coming the other direction, opening up to this arc over here. That means this angle opens up to that arc, and this angle opens up to that arc as well. So angle PSQ is also congruent to angle PRQ. 2 sets of congruent angles. When they open up to the same arc, they are both congruent. Both angles are congruent. All right, next, we want to find the value of each variable. So here we are now looking at that theorem 10.9. 10.9 tells me that the opposite angles of a quadrilateral trapped inside of a circle are supplementary. So if I want to find x plus 88 is going to equal 180 degrees. So, subtract 88 from both sides. X is 92. So it's 92. Oh, we're just finding the value of the variable. So I don't need to know the degree. So let's forget I even went there. X is 92. X is 92. Now if I want to find y, again, y and its opposite angle equals 180 degrees. Subtract 100 from both sides. Y is 80. All right. I want you to practice this with me while I'm doing it as well. So now, opposite angles are correct, supplementary. So 8x plus 4x equals 180. When I divide it, x is 15. Now let's do y. 3y plus 3y equals 180. So now y equals 30. Y equals 30. All right. Number 5. Number 5 again, we have two arcs. We're trying to find the measure of C and find the measure of angle A. Sorry, so we're looking for two angles. Sorry, I'm trying to find their measure. So angle C is right here, and I want to find its measure, and I want to find the measure of angle A over here. To do this, I'm going to have to use my properties and then put everything all together. So first, all right, we know what? That to find angle A, or we can start with C, sorry, start with C. To find angle C, we know that he equals 1/2 of this arc AB. Why? Because he's inscribed. So I know that the measure of angle C equals 1/2 arc AB. So let's put in some numbers here. We know that angle C is 5y minus 3. We know that arc AB, well, we don't know arc AB, but we know angle D right here. We know that angle D goes to arc AB and it's double, and because angle D and angle C open to the same arc, we know that angle D is congruent to angle C based upon that theorem 10.8 again. So, knowing these two are now congruent, all we do is set them equal. Now I'm going to go ahead and bring the 4y over. I'm going to go ahead and add 3 to both sides. So y equals 10. So now I want to do angle A. So I have angle A right here. He's 5x. He opens to this arc. So again, we know that he is half the arc, but I don't know the arc. But I do know that angle B opens to the same arc. So therefore, I know that angle A is congruent to angle B by, again, that theorem 10.8. So 5x equals 7x minus 8. So let's do our math again. Subtract 7x from this side, so I get negative 2x equals negative 8. Divide by negative 2, x equals 4. Now, you're saying, Ms. Singletary, you just found x and y. You did not solve for the angle. You're absolutely right. I did not solve for the angle yet. So now I need to go back and say, okay, y is 10. The measure of angle C equals 5 times y minus 3. So 5 times 10 minus 3, 50 minus 3 is 47. So the measure of angle C equals 47 degrees. Now I'm going to go back and do angle A. So angle A says it's 5x. So the measure of angle A is 5 times 4, so it's 20 or 20 degrees. Do not forget to go back and plug in those values. That's the biggest mistake people tend to make. All right, looking at B. B is a different theorem. B looks like I got a triangle trapped inside, so that's my theorem 10.9. So for theorem 10.9, it says that first, if CE is a diameter, then this has to be a right angle. So we know that his degree, if he's a right angle, is 90 degrees. So therefore, I want to find the measure of angle C. I'm going to have to find x first. So how many degrees are in my triangle? Correct. It doesn't change because he's trapped inside of a circle. So 90 plus 5x minus 12 plus 3x equals 180. So now solving this, I get what? 5, 6, 7, 8x plus 90 minus 12. 78 equals 180. I'm going to subtract 78 from both sides. Get 102. Divide by my 8, and I get 12.75 as my variable of x, and depending on if you're a good math student or not, it is 48/4. It's not 48, 49/4. Old people can't read, sorry. 49/4, 49/4. So depending on which one you want to use. If I'm plugging it back in, you could use either. Just depends on which your teacher prefers. Whether it's the decimal, but you're not really using the decimal. We're finding the measure of angle C. As long as your numbers come out nice, you're okay. So when you're plugging it back in, you can use either one, because we're finding here the angle here. If it was a final answer for x, typically we don't like decimals as we're moving in, unless it says to do decimals. But remember, never repeating. Never repeating. So now I want to find the measure of angle C. So C, it says right here, the measure of angle C equals 5 times my x, and I'm going to be slacky and use the 12.75 minus 12. So the measure of angle C is 51.75. And again, I'm going to use that math and or enter button because depending on your teacher, you might have to have the fraction. So the measure of angle C is 51.75 degrees or 207/4 degrees, however you look at that. Thank you for spending this time with me, and have a great day.